Well, the change must be inversely proportional to the period of time in which the change occurs. In other words, if there is a sequence of changes that are parts of a more comprehensive change, the changes that belong to a shorter sequence typically presuppose a greater number of permanent structural and sequential associations than the sequence constitutive of the more comprehensive change. This principle can be illustrated with numerous examples. Consider a simple one, the change resulting from heating a pile of wax. The change from the solid state to the liquid state presupposes the permanence of the same wax-like material. However, the next change from liquid wax to carbon ash presupposes only the permanence of carbon atoms. If the heat then becomes much more intense, carbon will lose its atomic structure, giving place to a superheated plasma of subatomic particles. We have here a sequence of 4 time periods. Regarding the shortest period of time, from T1 to T2, we assume that we will be left with the same wax, made up of 2, the carbon molecules and atoms, which in turn are composed by their same subatomic constituents. In the longer period of time from T1 to T3, we assume the identity of only 2 and 3, carbon atoms and subatomic particles. And in the still longer period of time from T1 to T4, the only things that remain the same are 3 subatomic constituents. Note that this model is not restricted to change in the physical material world. As Leibniz saw, natura non facit saltus. The same examples repeat in every domain that one can imagine: chemical, biological, psychological, social, economic, historical. With the same patterns, the closer the future is to its junction with its past, the more structural identities must be in some way assumed. For example, the process of industrialization. The Industrial Revolution was a period of social and economic changes, from an agrarian society to an industrialized society, which suffered an upheaval in the mid-19th century. As a whole, after its second period, it included the refinement of the steam engine, invention of internal combustion engine, harnessing of electricity, construction of infrastructure such as railways, and socially, the more complex exodus of families from rural areas to large cities where factories were constructed. However, when we choose to consider a short period in this process, for instance at the end of 18th century, the only outstanding changes were probably the invention of a simple piston engine and a minor exodus from the countryside, most characteristic of society, otherwise remained essentially the same. We conclude that it is intrinsic to the very structure of the whole of experience and of possible experiences that changes taking place in a shorter period of time tend to presuppose more permanence than the most comprehensive long-term changes within whose course they occur. Consequently, The future closer to its present should, as a rule, inevitably be more similar to its past in more aspects than more distant futures will, as different from the present. At the point of junction between future and past, namely the present, in our system, no difference will be available. Same with the other systems at the velocity of light and so near to the light and so on. This is not mind. Regarding induction, this principle assures that inductive predictions will become more likely the closer the future is to the present. On this basis, we can improve the principle PF asterisk as PF2 asterisks. As a rule, the closer the future is to the junction point with its own past, the more it will tend to resemble its past. The two being indistinguishable at the point of junction, namely the present. For a correct understanding of PF2 asterisks, we must add two specifying conditions. One, that this principle should be applied to a future that is sufficiently close to its past and not to an indefinitely distant future. Two, to safeguard the possibility of anomalous but conceivable cases in which we find shorter sequential periods where states of affairs of a more distant future are closer to the present than those of the near future and then changing again. Although I admit that PF2 asterisks still deserves more detailed and precise considerations, it seems to me intuitively obvious that, though understood, this principle already meets a reasonable standard of analyticity. Moreover, it is the truth of PF2 asterisks which explains why it is natural for us to think that the more distant the future, the less probable our inductive forecasts will be. This is the very familiar case of weather forecasts. They are presently reliable for 2 or 3 days, less for a week or more. It also explains why our inductive generalizations about the future cannot be applied to a very distant future. For instance, through induction we can infer that the sun will always rise, but always must be replaced in quotation marks here. On the basis of induction, it makes sense to affirm that the sun will rise tomorrow morning or even 1,000 years from now, but it defies common sense and is cosmologically false to use the same inductive basis to claim that the sun will still rise every morning in 70 billion years. How PF2 asterisk applies is circumstantially determined. If the future is sufficiently close to its junction with the past, then the future will be unavoidably similar to its past. The problem, of course, is that we need to establish criteria for judging how close in time the future must be to its past, so that PF will still apply. We can speculate as to whether the answer does not depend on the background represented by the domain of regularities in which we are considering the change, a domain of irregularities to which a whole system of sufficiently well-entrenched beliefs applies. For example, the inductive conclusion that the sun will rise tomorrow belongs to a domain of irregularities that may someday undergo changes predicted by contemporary cosmology. This may include a very distant future in which dramatic changes, such as the death of the sun, are also predictable, based on the astronomic observed fates of similar stars in our universe. Of course, it's always possible that the sun will not rise tomorrow. However, this is only conceivable at the price of an immense loss of older and well-entrenched beliefs about astronomical regularities, and subsequently the loss of the current intelligibility of a considerable portion of the physical world around us. Still, what makes us consider as highly likely the future occurrences of irregularities such as that the sun will rise tomorrow? The ultimate answer seems to be based on the inevitable assumption that our world will continue to exist as a system of regularities, at least in the form prescribed by PF2 asterisks. However, this assumption seems to be a blind gamble, and I agree with it. After all, there is nothing preventing our whole world from suddenly disappearing. However, this is the impression of a paradox. The impression of a paradox evaporates as soon as we consider that this hypothesis is completely unverifiable and therefore senseless. Another part of this book, arguments against verificationism, a kind of verificationism, are totally debunked. Mainly the positivist and post-positivist. Remaining is only Wittgenstein's verificationism. They have misunderstood Wittgenstein terribly. However, the impression of a paradox evaporates as soon as we consider that this hypothesis is completely unverifiable. If our whole world suddenly disappears and there is no order, how can we know this after we have also disappeared with the world? Now, if the hypothesis is unverifiable, it must be senseless. It is in its lack of sense the question, remember, the entropic principle. The question, why is possible that we are able to think the world, loses its sense as soon as we consider that under infinitely many possible worlds, this is one under the few able to produce conscious beings able to pose this question. In contrast, the hypothesis that our world will continue to exist can be verified in the future. Hence, it is meaningful. Because of this asymmetry, we are free to accept that since we cannot really think that there will be no future at all, the regularities of our world will need to take the form prescribed by PF2 asterisks. That is, we are inevitably led to admit that certain domains of cohesive regularities will have some permanence. The above outlined argument concerns just a single form of induction from past to the future. Nevertheless, the attempt to better specify it and to generalize about further developments would be worthwhile, since it suggests a path free of unsurmountable hindrances. This may be of some interest regarding a problem that from any other angle seems to remain disorienting and intangible.